Hi everyone. My survey topic is about interpretable machine learning strategy, and I will start from a new view to conclude and summarize the related method. The main content of my presentation is about interpretability and its categories, a new perspective and the related strategy from this perspective, and the conclusion. The reason why I choose this topic is that AI is powerful and its conclusion often surprises us, and a couple of questions are often asked it, like why come to this conclusion, whether the conclusion is dependable. If it's not 100% sure, when will something go wrong, and can I understand the reasoning process? To understand the interpretability, let's first look at the definition from other people. An interpretation is the mapping of an abstract concept into a domain that humans can make sense of. There are some limitations in this definition. First is human sense is too complex and unclear. The second is this definition does not reflect the division of labor between subject and object in understanding the event. So we need to redefine the interpretability to categorize more clearly. Thus, we can come up with the new definition, which is suppose the method of agent B is used to solve a task. If the effectiveness of the method F can be recognized or even reasonable by agent A, then we can say F is interpretable to agent A. The new definition emphasizes two things. First is interpretability involves both sides, and the second is interpretability is the relationship between two agents. Currently, interpretability can be divided like following categories: local post hoc, local self-explaining; global post hoc, global self-explaining. But we can say that there are some limitations in this classification. First is it doesn't specify what causes global or what causes local. The second is who performs the computation for reasoning. In my words, does agent A or agent B perform the computation? Since an essential characteristic of machine learning is dynamic evolution of the system, so we can come up with the following term: evolutionary dynamic. Evolutionary dynamic can divide the system into explicit or implicit. If the methods and the process of learning is visible to the outside, then it's explicit, else it's implicit. Second is state representation, which means state representation of the system. If the representation calculation is performed inside the system, it's tight coupling. If it performed outside of the system, then it's loose coupling. So currently, we can sum up with 6 categories. First is pure explicit dynamics. Second is meaning explicit dynamic. The third, explicit implicit synchrony dynamics. Fourth is pure implicit dynamics. Fifth is implicit dynamics, tight coupling represent. Sixth is implicit dynamic, loose coupling represent. Pure explicit dynamics methods belong to explicit dynamic and explicit representation. Each layer has explicit task. The process, the status, and the result can be explicit. The process can be re-reasoned, re-evaluated, or re-simulated by another agent, and the examples of this category have regression, decision trees, genetic analysis, expert system. This category has good interpretability. There is no interpretability problem in this category. The other one is meaning explicit dynamics. It's explicit dynamic on the whole body but contain implicit dynamics. For example, neuroadditive method. Neuroadditive method is proposed which combines some of the expressivity of DNA with the inherent intelligibility of generalized additive models. That is to say, the subnetworks are not interpretable, but the result of each component we can understand, and the overall is a weighted summation network, and the final result can be understood. The other example is Tensor. Tensor is a novel evolutionary approach for automatic generation of DNNs, which combines the overall method genetic analysis with those of dynamic structure grammatically evolution. These examples are all have good interpretability on main body, but contains part network that are hard to understand. And there are some limitations in this method. It's not always more powerful than implicit dynamic. The next one is explicit and implicit synchronous dynamics. This method contains both explicit and implicit dynamics. Can't find any example for now, but it can be exist. Compared with GAN, it can use two models to compete, and the explicit model can give interpretations to the outside. And the advantage of this method is that it has diversity dynamics, which can benefit the model optimization, and can also interpretable to the outside. The pure implicit dynamic. The feature of this kind category is that it's kind of implicit dynamic and no state representation. For example, DAN. The interpretation of this kind is hard to explain. The only possible to explain is from two aspects. The first is what kind of input the network pay attention. The second is the more output append. Implicit dynamic tight coupling represent. This category has implicit dynamic and tight coupling represent. The first example is 3D GAN, reasoning from latent state space to what 3D shape the object is. The latent space is the pattern that exists in network. Take this kind of data can be interpreted. This is kind of semantic representation of the automatically formed object. The second example is VidGAN. It's kind of visual transformer. For example, you enter a human face, you can make him grow fat, grow a beard, or become young, or become Picasso style. On the slide, this example, through the multi-layer perception, the subgraph can show that it's cat ears or cat hair. We call this method implicit because the connection between some weights and the required picture cannot be seen as impressible. We call it tight coupling represent because this expression of forming subgraph can be understood as the expression of subgraph is necessary for the reasoning process. The graph is for for their own reasoning. The last category is implicit dynamic loose coupling represent. The so-called IDRL only currently have to use some visual method to interpret. In the end, the conclusion of my survey have 5 points: defining interpretability, emphasize on agent and interact, propose a new perspective and 6 categories, survey 6 strategies examples and their implements, propose a EISD based on GA and GAN, emphasize on EISD and IDTR, be optimistic about the development of these 2 categories. And that's the end of my presentation. Thank you.